Today we're going to talk about Chapter 6. In Chapter 6 there's a lot of math, and I want to help you with some sample problems. But Chapter 6 is all about chemical composition. And composition in the sense of what it's composed of, what it's made of. And so we're going to look at how scientists can study mathematically what chemicals are made of in terms of how many atoms they're made of, how much mass they're made of. We already talked about molar mass. So those are the types of things that we're going to learn in Chapter 6. So I want to actually go over some sample problems that will help you both in doing the self-checks for Chapter 6, which is the homework for this week, and also next week's homework. So the first topic is atomic mass units. And atomic mass units are just an easier way of weighing atoms because, of course, kilogram and gram is much too large a unit to weigh an atom. And the nice thing about atomic mass units is that for any element, okay, for one atom of the element, whatever one you're studying, equals the atomic mass for that element. I guess I should say of the element. Okay, so an example would be like carbon, for example. So one carbon atom equals 12.01 AMU. And this is just an abbreviation of atomic mass unit. Okay, so if you look at the periodic table, and just so you know, an easier way to do this is to look at the front cover of your book, and it lists alphabetically all the elements and their atomic number and their atomic mass. If you look up carbon, you'll see that its atomic mass is 12.01. Okay, so that's a little background that we need so that we can do some self-checks and some sample problems. Do for you the first one, page 188, and this is number 5E. And you have 891 atoms of iron, which is Fe, and we want to know how many AMU. So that equals how many atomic mass units. So you start by writing down the information given in the problem. And you look up iron in that list, and its atomic mass, you see, is 55.85 AMU for every one atom of iron. Okay, your calculator spits out a rather large number, and you know, we studied significant figures in Chapter 5. This problem, it's a bit complicated, but you know, we'll just say that this is the sig figs that we want to look at, right? This has 3, this has 4, so we round off to 3 sig figs. It's a little more complicated than that, and I just want to tell you from here on out, I'm not going to do double jeopardy on sig figs. Okay, what that means is, you know, on a test, I'm not in Chapter 6 testing you on significant figures. I'm testing you on, can you set up a problem like this? So just a rule of thumb, you can round off to about 3 sig figs on a test, and you'll get the right answer, okay? What I don't want to see is you giving an answer like like this one on a test. I'm hoping that you know by now that this is way too many digits, right? If we're only starting with 3 here and 4 sig figs here, you shouldn't be writing down an answer with all these digits from your calculator, okay? So as long as you know that and you have about 3 sig figs in your answer, that's fine, okay? Just going forward, all right? So this is your answer to that problem. And yes, these are problems that I'll assign for next week, and they're also very similar to the self-checks that are due next block day. So really, when you go home to do the self-checks, all you need to do is plug in different numbers from these and you'll get the right answer. So you set it up the same way. But as you already know, you can always look in the back of the book at the self-check explanations. So I'm both giving you problems that look like the self-checks and the homework for next week. Okay, moving on. So the next problem, this is going the other way. So you're given the AMU for aluminum, and you're asked to find the atoms. Well, we're just flipping over the conversion factor. And you can do that, remember? Depending on how you want to solve the problem, you can flip the conversion factor over. So this number, 26.96, is just the atomic mass of aluminum. And that comes out to be 133.0 atoms of aluminum. And I'm rounding off to 4 sig figs because this has 4 sig figs. This has 5, and that has 4. So we take the least number of sig figs, and this is what we get. 133.0 atoms of aluminum. And again, in your calculator, you take 3,588.3 divided by 26.98. Okay? So, I'm going to talk about the mole using 16D, page 188. Okay, equals how many moles of cobalt? Well, we write down what we're given. We want to get to moles of cobalt. Okay, I don't want atoms in my final answer. I'm going to put them on the bottom so that they cancel out. Bye-bye. I want moles in my final answer. Those are going to go on top. For every 1 mole, how many atoms do we have? Remember, a mole of anything is 10 to the 23rd power. So when I do 5.99 divided by 6.022, I get 0.995. But I got 10 to the 21st divided by 10 to the 23rd, right? This and this. And that equals 10 to the negative second. Right? Because I subtract my exponents. So we got to change that to good scientific notation. If I make the 0.995 10 times bigger to make it 9.95, I need to make my 10 to the negative second power 10 times smaller. And this is my final answer. And this is a lot like the problem you guys did in the chalk lab where you wrote chalk on construction paper. Now I'm actually going to continue this problem more than what it asks for in the book because it'll help you in your self-check. So I'm going to take the answer that we have and I'm going to change it to non-scientific notation just to save some space. And I'm going to convert that to mass. Okay. This is sort of like one of the self-checks you're going to do for homework. Oops. Okay, we're trying to get to grams of cobalt. So remember, whatever units are you want in your answer, put it here. Okay? We do not want moles of cobalt, so put those down here. Grams per moles. Look at that, grams over moles. You know that that's the molar mass. So for every 1 mole of cobalt, you look up the molar mass in the periodic table and you see that it says 58.93. So this is just multiplying 0.00995 on your calculator times 58.93 equals 0.586 grams of cobalt. So in that way, we figured out also the mass. So there's a self-check problem due on next week's homework where you have to figure out both moles and mass, which we have done. Okay, next do page 188, number 19D. Okay, and this is just molar mass. So this is a little easier. I think we all had an easier time with this on the block day recently. So for this one, we're figuring out the molar mass of ethyl alcohol, okay, which is C2H5OH. So we have to do 2 times carbon plus how many oxygens do we have? 1, and we have 1, 2, 3, 4, 5, 6 hydrogens. So that, then we look those up on the periodic table. And that comes out to be, when we add it all up, 46.07 grams per mole. So ethyl alcohol has the molar mass of 46.07 grams per mole.